We are the group 2 and we are here to discuss the solar power home, the solar thermal, and also the photovoltaic system. Solar power home. There are three types of solar power home: the grid tied, the off-grid, and the hybrid. Let's focus for the grid tied. Grid tied is connected to the home and to the traditional electricity utility grid. Type of the solar power system does not include any storage battery. Yung grid tied is wala siyang battery. Next naman is yung off-grid. Stand-alone system that is completely disconnected from the electric power grid. Contain large set of battery packs which store energy during the day to be used at night and when the intensity of sun is low. Sa off-grid is may battery siya. Tapos, nagko-collect siya ng energy from the sun during day para ma-store yung electricity, na magkaroon ng electricity during night and pag walang araw. Next naman is hybrid. Grid interfeed solar power system is also connected to the traditional utility power grid which contain battery backup. Sa hybrid then is may battery. The addition of the battery backup enable the system to work there is a power interruption. Dito naman pag may power interruption, para gumana pa rin yung solar panel kasi meron siyang battery. Grid tied. Connected is parallel to the electric supply that goes into the house and function in day only. Sa grid tied, nagpa-function lang siya pag during day. Di siya magpa-function during night kasi wala naman siyang battery backup na ma-store na energy to produce electricity. Sa grid tied then is there is no battery backup. It does not produce power at night. Dito nga hindi nagkakaroon ng nagpo-produce ng power during night. Pang ano lang siya, pang during day. Tapos during brownout, the solar power system is also shut down. State does not produce electricity. Pag naman may power interruption, wala din siyang supply na electricity kasi wala nga siyang battery backup. The main purpose lang ng grid tied is to save electricity. In fact, where solar array rating matches the electric consumption, zero bill can be attained. Ang purpose lang ng grid tied is males or mga-save ka ng binabayaran na bill. Kaya magkakaroon siya ng zero, kaya hindi ka magkakapagbayad ng electricity or you will attain the zero bill. Solar panel utility pole, solar panel inverter and meter. Solar panel powered home is composed of solar panel, grid-tied inverter with or without limiter, DC circuit breaker, DC surge protection device, AC circuit breaker, AC surge protection device, time delay switch, DC AC electrical wires, MC4 connection, and solar rails and clamps. The MC4 connection, solar rails and clamps is the minor lang naman na parts ng solar panel home. Tapos, the heart of the solar power home is typically or solar cell will only produce around half of a volt. So, by connecting them together in series inside the panel, a more useful voltage is achieved. Next naman is most small solar panels rated 150 watts or below are rated as 12 volt, while larger solar panels are 24 volts. A 12 volt solar panel produces around 14 to 18 volts when put under load. The solar panels can be connected together to current to create a solar array. The output of a solar array is computed like a battery. Series connection increases the voltage while current remains the same. Parallel connection increases the current while voltage remains the same. When you connect multiple panels together, the power of the overall system increases regardless of whether they are connected in a series or in a panel. Next naman is the monocrystalline has a color black, or ito yung may mga black hole. Tapos polycrystalline is the color blue, or yung mga blue hole, yung may mga meron na blue hole. Tapos naman is, let's discuss the inverter.
So, good day everyone. I am Jinmiko M. Kitan from BSE 3B. So, ako nga pala yung susunod na reporter kay Nika. So, solar-powered home grid tayo. Next. Next slide. So, parts and function. So, didiscuss ko ngayon kung ano nga ba yung mga parts and function na ginagamit sa solar power or solar panel para makabit ito or magamit ng mga ito. So, pinakailangan is inverter. So, inverter. An inverter is one of the most important pieces of equipment in the solar energy system. It's a device that converts direct current, electricity, which is what a solar panel generates, to alternating current, electricity, which the electrical grid uses. So, next slide tayo. So, different types of inverter. So, ito yung mga different types ng inverter natin na mabibili natin para makapagkabit ng solar panel. So, meron tayong Pronius. So, yung Pronius dito is yung pang-apat. So, makikita nyo para siyang robotic style. So, yung iba dyan is mahal and then yung iba naman mura. So, piliin nyo kung saan naabot yung budget nyo pero maganda yung gagawa nyo. So, next. So, meron pa tayo tinatawag na pure sine wave inverter and modified sine wave inverter. So, mamaya i-discuss ko kung ano ba yung tsura nitong dalawa. So, design mo natin yung definition ng pure sine wave inverter. A pure sine wave inverter is a device that converts direct current power from a battery or other DC power source into high quality alternating current power similar to the power you get from a standard electrical outlet in your home. This inverter provides a smooth and continuous waveform that swing up and down in a perfectly symmetrical pattern. This mimics the sine wave pattern of the AC power supplied by your local utility company. So next. So a modified sine wave inverter, or we can call it a quasi wave inverter. So actually has a waveform more like a square wave but with an extra step. So a modified sine wave inverter will work fine with most equipment, although the efficiency of power of the equipment will be reduced with some. Due to the modified sine wave inverter construction, these inverters are often more affordable than their pure sine wave counterparts. This type of inverter may be the optimal solution for larger projects that require less efficient power. So, ano nga ba yung pinagkaibahan ng pure sine wave inverter and modified sine wave inverter? So, next. So, ayan, makikita nyo yung sa left side natin is a pure sine wave inverter and modified sine wave inverter. Yung pure sine wave inverter, pa-alon-alon siya. And then yung modified sine wave inverter naman is a square step. So, para siyang hagdan. So, yun yung pinagkaibahan nila sa tsura. Okay, next. So, DC circuit breaker. Direct current circuit breaker protects electrical devices that operate on direct current. The significant distinction between direct current and alternating current is that the voltage output in DC is constant. In contrast, the voltage output in alternating current cycle several times each second. So, yung DC circuit natin is pinaprotect nito yung electrical devices na nag-operate sa direct current. Next. AC circuit breaker. A circuit breaker refers to a mechanical switching device capable of making, carrying, and breaking current under normal circuit condition, as well as making, carrying for a specified time, and breaking currents under specified abnormal circuit conditions, such as those short circuit. So, next. So, dito makikita natin, yung nasa left side is yung kulay red. Ito yung DC circuit breaker natin, and then yung kulay blue is sa AC circuit breaker. So, kung makikita nyo, meron siyang apat na tornilyo, and then kapag tinanggal natin yung tornilyo na yon, doon natin ikakabit yung mga wire. Yung wire na yon, ilalagay natin sa input side. Yung sa left side, ito yung positive, and then yung sa right side, ito yung negative. Or kapag meron naman tayong wire na kulay red, ito yung positive, and then yung black is the negative. Iipit natin doon, babalatan natin yung wire, iipit natin. And then, ko-connect na natin muna sa may sa may grid natin. So, same lang siya ng AC circuit breaker. So, next. DC surge protection device. It protects electrical installation against direct lightning stroke. It can discharge, it can discharge the back current from lightning spreading from the earth conductor to the network conductor. So, dito yung DC surge protection device, protect niya naman yung electrical installation against direct lightning stroke. Nadi-discharge niya din yung back current from the lightning spreading galing sa earth conductor to the network conductor. Next, AC surge protection device. A surge suppressor, sometimes mystically called a surge protector, is a device inserted in the alternating current utility line and or telephone line to prevent damage to electronic equipment from voltage spikes, or we can call transient. A more accurate term for this is type of device is a transient suppressor. So, this is surge protection device. Na-optimize niya na yung device na to is meron siyang ini-insert na alternating current utility line para sa telepono para mapag-prevent ng damage sa electronic equipment natin galing sa voltage spike. Next. So, ito yung tsura niya. So, sa left side natin yung kulay orange is a DC surge protection device, and then yung white naman is a AC surge protection device. Ayan. Next. Time delay switch. Time delay switch, also known as time lag switches, switch on the connected appliance for a preset length of time in order to save energy. This reduces the impact of forgetting to turn off the light, heating, or ventilation. So, time delay switch, kapag nakalimutan mong i-open yung ilaw mo or yung ventilation mo, pwede kang mag-set ng time na para ma-delay na ma-open to. Hindi mo man siya ma-open on time, ma-open man siya mga ilang segundo, mga late siya ng 5 seconds, 2 minutes, gano'n. So, next. So, ito yung itsura niya. So, yan, meron siyang 5, 10, 15, 20. So, next. So, dito naman sa programmable timer switch. So, yung programmable timer switch naman, ito yung pwede mo i-program na kahit ilang oras, kahit anong minuto, kahit anong segundo mong gustong iset yung pagsindi ng ilaw or yung ventilation na gagamitin mo o yung water system mo. Kasi nga automatically na mag-on siya. So, time-saving programming by a selection of daily blocks, individually adjustable or selection from preset blocks Monday to Friday and Monday to Sunday. Ideal for controlling lighting, ventilation, water system, heating, and cooling circuits. Ang benefits nito ay nag-override ng switching option. So, next. So, ito yung itsura niya. Kung makikita niyo yan, kung makikita niyo na PC man kayo or laptop, makikita niyo yan na meron siya nakalagay na hour, seconds, and minutes. Kung kailan niyo gusto. Yan. Digital na siya. So, yan. Next. So, net metering. Net metering ay ang batas na kung saan pwede tayong magsagawa ng batas na mag-provide ng sarili nating renewable energy. So, yan. Meron na rin yan dito sa Pilipinas. And then, Na-approve siya nung, kalimutan ko. So, basahin lang muna natin yung uh, definition. A system in which solar panel or other renewable energy generators are connected to a public utility power grid and surplus power is transferred onto the grid, allowing customer to offset the cost of power doon the utility. So, yun yung net metering. And then, kapag lumagpas ka sa net metering na tinatawag, meron kasi yung tinatawag na parang may sakop lang siya, no? Mga, like, for example, 10 meters, ganun. Kapag lumagpas ka doon, magbabayad ka na. Ayan. Next. So, doon na natatapos yung report ko. Ang next na reporter is si Renzi. So, ipagpapatuloy niya yung report ko. So, yun lang po. Salamat.
So, hello everyone. My name is Bong Christopher Mercado from BSE 3B. The next reporter. So, question number 5. Who are qualified to participate in the net metering program? So, dito, basta daw may kontador yung bahay nyo, pwede ka mag-participate sa net metering. Lalo na kung ikaw ay good customer at saka wala kang utang sa distribution utility, pwede yun. And di naman pwedeng hindi ka payagan mag-participate dito ng batas dahil nakasulat doon na pwede ang lahat na sumali doon. So next, consequences of not applying for net metering. So, in the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. So, dito, lahat daw ng excess energy na maano sa solar power system ay mabibild sa customer. So, parang kung kailan ka pa nagkabit ng solar power sa bahay mo, tsaka pa lalaki yung bill mo. So another question is there other way beside net metering that a customer having a solar power system producing excess energy during day and yet will not pay for it? So the answer is yes, because this can be achieved by using an inverter with limiter. This device limits the power that system will dissipates. It automatically detects the maximum power that the system can provide without excess being sent to the grid. So dito, yung inverter with limiter daw, kapag na-achieve na niya yung maximum ng power, automatically mag-shutdown to. So next is solar-powered home circuit connections. So dito, this is the most basic connection that we imply on grid-tied setup. Ito yung pinakamatipid na circuit na pwedeng gamitin sa solar-powered home. Next is, we have time delay switch and programmable timer switch. But this diagram only represent the AC side of our grid-tied setup. Wala dito yung DC connection sa diagram, or this connection represent the interconnection of parts after the inverter. Wala dito yung connection of parts between solar panel and the inverter. So this is the combining the two that we have this setup. So before we start, pag-usapan muna natin yung different connection that different contributions utility implies. Yung iba-iba daw kasing distribution utility, iba-iba din yung connection na ginagamit nila. Parang si Cellcore at si Meralco. Ang connection nila line to line, meaning yung dalawang wires na pumapasok sa residential building natin, they are both wires 110 volts or maybe even same 115 volts. So doon naman sa ibang distribution utilities na merong connection na line to neutral is isa lang yung live wire doon, mostly is 220 and yung isa neutral, or 230 and the other one is neutral. So kaya natin dapat malaman to dahil lahat ng line to line, parang si Cellcore at si Meralco, lahat ng black and red wires within circuits pwedeng magkabaligtad. Pero if the distribution utility were line to neutral ng wires ay hindi pwedeng magkabaligtad dahil pwedeng makasira ng system natin or pwedeng o di pang sumabog yung system, lalo na yung mga vital parts. So yun, take a look at this diagram. So makikita natin na isa lang yung solar panel dito. Kahit madami tayong gamiting solar panel, kahit ano yung connection that we're going to imply, series, parallel, or combination of both, there will be only two wires that will come out from the solar arrays. And from that two wires, we're going to interconnect the input side of our DC circuit breaker. And then, of course, being a DC circuit breaker is a polarity. And the positive and the negative can be interchanged. So, next is we're going to connect the DC SPD in parallel to the input side of DC circuit breaker. Ito. Which label as positive and negative, being a direct current surge protection device. And this portion is routed to our grounding conductors, which is connected to interconnected towards our grounding electrode. So yung conductor which is connected to grounding electrode, which is buried to the ground, dito makikita na din natin yung lahat daw ng green na yan. Green wires na yan ay grounding conductors at sila ay interconnected towards the grounding electrode. Ito, grounding electrode. So let's move to AC side from the service conductor. Service entrance conductor. Ito. So the service entrance conductor will go down from the energy meter and will goes down the main circuit. Ito, the main circuit breaker coupled with grounding terminals. So next is the main panel board. We're going to get a circuit breaker and we will going to connect RCBO. Ito. So next is from the main panel board, we're going to get a circuit breaker. We're going to connect the RCBO. From the input side of RCBO, ito, which is labeled as line, neutral, and ground. Pero yung ibang brand daw kasi ay yung ground daw ang tawag ay PE, meaning protective earth. So this is not belong to our grounding connector. So dito kung tayo ay nakakonect sa distribution utility na line to line tulad ng Cellcore nga tsaka Meralco, pwedeng magpalit ang line at neutral pero kung ang distribution utility naman na naka-connect tayo ay line to neutral, so dito hindi pwedeng magkabaligtad yung yung live, tsaka yung neutral. So let's continue. Yung output ng RCBO, ayan. Ito. Yung output daw ng RCBO, na-connect sa input side ng AC SPD. Ito. So, ito naman daw dalawa na to, pwede nang wala na yung dalawa na to kung nagtitipid tayo. Pero kung may budget ka naman, ibigay mo na yung ilagay mo na yung dalawa na yan para din sa smoothness of operation of our grid-tied solar powered home. So to connect the two remaining parts, input side of time delay switch, and input side of AC SPD dapat naka-connect in parallel. Tapos yung output side ng time delay switch ay naka-connect sa programmable timer switch. And in this portion of programmable timer should be connected to AC out of grid-tied inverter. So, yung inverter ay wala siyang limiter. So, under the circuit, you need to apply for net metering or internal limiter. Ayan. Ito. Yung inverter, you just need to connect the wire of any of the two wire if the connected to distribution unity where the connection is line to line. So ito, pag daw naka-under ka sa connection wherein line to line, pwedeng kahit saan dyan yung internal limiter. Pero kung ikaw naman ay naka-under sa distribution utility na line to neutral, dun mo lang siya ikakabit sa live wire. So, ayan. That's how we are going to connect the solar-powered home grid-tied. Next is solar-powered home size wiring. Wire sizing. So dito number 1 is THW or thermoplastic wire. So dito so yung thermoplastic wire, ang thermoplastic wire daw kasi, ito yung, ang meaning daw nito, yung moisture resistant and flame retardant. So itong TW na to, hindi agad siya masusunog. Tsaka moisture resistant siya. So next is THW or thermoplastic heat resistant wire. So dito, yung thermoplastic heat resistant wire ay parang ganun din siya sa dito, sa TW. Pero mas mas malakas yung heat resistant niya kaysa sa TW. So number 3 is THHN or thermoplastic high heat resistant nylon coated. So dito, thermoplastic high heat resistant nylon coated, designed for specific insulation material, temperature rating, and condition of use. So suitable for dry and damp location. So etong THHN, yung nadagdag na H dito ay yung high. Tapos yung N nylon coated. So dito parang mas angat siya sa number 2 at number 1 na THN at TH na at TW. So next is yan, THHN or THWN or thermoplastic heat and water resistant nylon coated. So, bibigyan ko lang kayo ng konting background sa THHN-THW-2. So, dito naman, yung THHN/THWN daw ay separated to sa mga store na mabibilan dati. So, pero ngayon, magkakasama na sila kung saan sila nabibili. Kung saan nabibili yung number 3 to 1. So, itong number 4 na to, mas mahal siya, pero mas magandang gamitin sa wirings. So, dito, yung THHN daw, 75 degree centigrade lamang siya. At yung THWN daw ay 90 degree centigrade lang. So, in both wet and dry environments to mas nababagay. So, ayun, maraming salamat po sa pakikinig. Thank you very much.
So note, here's a breakdown to help make some sense of the lettering. So the T stands for thermoplastic insulated cable. So next is the single H. It means the wire is heat resistant. And then the double H or HH means that the wire is heat resistant and can withstand with a higher temperature. Next is the letter N. It means that it's nylon coated. And then the added W signifies that the wire is also resistant to water. Next is PB wires. So this type is an exclusive kind of wire created of PB applications. So these cables behave extremely well in very hot temperatures and other harsh environmental conditions. Its special characteristics compared to other wire is its insulation and outer sheet, which is made up of XLPE or EPR. XLPE is an acronym for cross-link polyethylene. So XLPE is a thermosetting polymer, meaning that the material is cured under heat and in that process forms bonds in all direction, forming a three-dimensional matrix. EP means ethylene propylene rubber. So yung mga PB wires daw ay na ito ay okay siya kahit na sa mainit na temperature dahil sa mga special characteristics nito na at binubuo ito ng mga magagandang klaseng material. So dito naman yung mga wire sizes or size ng wires. Ayan. So next is the steps in PB system conductor sizing. So first, look for the ISE rating of PB cell. So second is multiply by 2 safety factors irradiance and continuous duty. So, number 3. Refer on the table 310.15 for the size of wire. Ayan. So, number 4. Refer on the table 310.15 for ampacity correction due to ambient temperature more than 30 degrees Celsius. So, number 5. Refer on the table 310.15 for ambient temperature adjustment due to conduit or wire distance from the roof. So, number 6 is refer on table 310.15 for adjustment due to more than 3 wires inside the conduit. So, 7, find the adjustment due to voltage drop. And number 8, the value obtained in the last step will be the basis of the size of wire to be used in the PV system. Find the proper wire size for a grid-tied PV system consisting of 3 just solar panels connected in series with specs at the previous slide. So, ang magiging example natin is the just solar. So, step 1, look for the LS rating of PV cell. So, makikita natin dito na ang LSC rating niya is 9.75 ampere. So, next, step 2. Multiply by 2 factors, irradiance and continuous duty. So, dito naman is, kailangan natin siya i-multiply ng 2 beses sa 1.25. So, 9.75 ampere times 1.25 times 1.25 is equal to 15.23. Next is step 3. So, refer on the table for the size of wire. So, tingnan natin sa table kung makikita natin sa table ang katapat ng 14. So, bakit 14? Dahil ang nakuha natin kanina ay 15.23 at dun siya pasok. At ang katapat ni 14 ay si 25. Pero hindi nire-recommend ng mga experts ang 25. So, ang gagamitin na lang natin is si 12. So, ang katapat naman ni 12 ay si 30. So, the table indicates number 14 THHN with an ampacity of 25 ampere. Since 14 AWG is not the best practice for PV system, yun nga. Kaya ginawa nating 12 yung THHN na ginamit natin na ang ampacity ay 30 ampere. So step 4. Ampacity correction due to ambient temperature. Since Philippines ambient temperature is around 37 degrees Celsius. So, tingnan natin sa table kung saan papasok si 37 degrees Celsius. So, kung makikita nyo, pasok siya sa 36 to 40. So, ang katapat naman ni 36 to 40 is si 0.91. Kaya, imumultiply natin ang value natin sa 0.91 at ang magiging sagot niya is 27 ampere. So, step 5. Ambient temperature adjustment due to roof wire distance. So, ito naman kung malapit siya sa bubong o kung anong layo niya sa bubong. So, tignan natin sa table kung above roof half inch. So, sa table na ito ay 22. So, palagay natin half inch yung layo niya sa bubong. So, sa table, ang katapat ng half inch is si 22. So, i-add natin to sa nakuha natin kanina na 37. So, 37 plus 22 is equal to 59 degrees. So, tingnan natin ulit ang 59 sa table. So, pasok siya sa 56 to 60 ang 59. At ang katapat naman ni 56 to 60 is si 0.71 at imumultiply naman natin si 0.71 sa 27. Dahil 27 yung nakuha natin kanina sa step 4. So 27 multiply to 0.71 is equal to 19.17 ampere. So, since 19.71 ampere ang nakuha natin at pasok siya sa 15.23 ampere na nakuha natin sa step 2 kanina, is our selected wire is the number 12. Mag-fit siya.
Okay, so my name is Jan Michael Nolian, and I'm here reporting PB, system conductor sizing, or maybe the step 4. So dito na makita natin yung table, which is magagamit natin mamaya. Note lang yung above roof at saka yung where it is? Ay, on roof. Ayun, on roof, tapos nasa above roof. Ang pagkakaiba nito, ito 2011, tapos ito ay 2014. So, next. So, matulad nito nung kanina, ambient temperature to bale. Yung mga gamit natin mamaya. Mostly, yung mga gamit natin to 91. Okay. Find the proper wire sizing for a grid-tied PV system consisting of 3 solar panels connected in series. Okay. So, dito na ako pinagsimula nung nahati. So, ito pinigay sa akin. Step 4. Correction due to ambient temperature as Philippines is recorded to have ambient temperature of 37 Celsius degrees. By using the table, okay, from the step 3, that is, wait a second. Using the table and the answer from step 3, that is 30 amperes. Checking again. So, 30, see, 37, ito. Ambient temperature. So, makuha natin itong sinabi ko kanina. Correction factor 90 degrees Celsius sa conductor, 0.91. So, where's it? Doon nakuha to. So, i-multiply natin siya sa 30 amperes o 30A. Makuha natin itong 27 amperes. So, ito na yung bago nating new wire ampere. So, sa step 5, if we distance our solar panel by 1.5 inches above roof, note that. So, ito magiging calculation niya. 37 ambient temperature times 22 above roof. Kanina sinabi ko. Above roof. Here ito. Where is it? So, 37 ambient temperature multiplied by 22 temperature natin nilagay. So, 59 degrees Celsius yung bago nating ambient temperature na maramdaman nung, what's it again? Conductors. Next. So, itong mga values natin, 59 Celsius yung ambient temperature. Okay, baliktad ata. No. 59 yung ambient temperature, 27. Yeah, baliktad, sorry. So, using the table earlier, we will get the 0.71 correction factor. So, let's see again. 27 or 59. Again. Sa yung table na yun, may makukuha tayong, doon makukuha yung 0.71 from 27. 27. Dito. ay ito. Yun. Ayun siya. 56 from 59. So, doon ang galing yun. So, mag-equal siya ng 19.71 ampere. So, ito na yung final wire ampacity natin. Since 19.71 ampere is greater than our load, it is 15.23 ampere. Therefore, yung selected natin na number 12 na thermoplastic high heat resistant nylon coated wire from the other step, which is I think iba yung reporter, will fit the system. Furthermore, babypass na natin yung step 6 kasi dahil sa set natin na medyo ano lang yung wires. So step 7 o setup. Step 7, sorry again. Adjustment due to voltage drop of less than 3%. So formula doon ng voltage, voltage drop is 2IR. Why? So bakit daw dalawa? Kasi may dalawa tayong wires na positive and negative sa may system natin. So ito yung formula. So yung yung R mag-equal dito sa K, which is constant. I mean DC constant. L as length and A as area. Makita natin sa next slide. So ito. God, nice. Dapat ikukin. Tinutan kayo na ito. So, ito yung length. Ito yung area, which is from here. Ito. Dito sa may AWG cross-sectional area table in centimeters. Meron ako sample nito mamaya sa dulo nga lang. Hindi ko na-like kasi di kasya, pasensya. The direct current constant value to be used for copper is 12.9 ohms. So, doon na-explain bakit may 12.9 doon. So, ito yung 2 kanina. 2 tapos 0.93. Which is, ba nakuha itong 93? Dito. Tapos yung 12. Itong 25 feet ata, if I remember correctly, assumption lang siya, ay nakalagay, assumption. Tapos tong 9.3 from Just Solar here. Sa table na to nang galing. Makita nyo naman dyan. So, here, ito hindi ko mabasa. Parang yung, so get the percentage of volume drop. So, 0.92 divided by 32.26 multiplied by 100%. So, ito, ganoon lang siya. Basic lang naman siyang math. Wala na transpose, wala na ding whatever. So, ibig sabihin na to, less down ng 3% ang natin. Nang sinelect natin 12 na ano yung kanina? THSN. Itong 12 kanina to. Which means, sakto lang sa system. Pero, medyo malapit siya sa 3. So, ito. Since it is close to 3, it will be better to use the 10 wire sizing for the final safety precaution. So, but in case it exceeds 3%, so ito. 2 times 9.3, 12.9. Ito yung kanina. Second. Itong 10,384 nang galing dito sa may 10. Ito. Ayun. Galing dito. If mababago daw yung value. So, ito yung magiging resulta niya. Which is, ano ko ba explain to? parang kaninang ano lang eh, parang kaninang computation lang din. Kaso ito, kung mas maano yung percentage niya sa baba o nag-i-exceed. I mean, nag-i-exceed pala. So, ito makukuha. Saan na yun? Where is it? 10, 384. Divide bit, nag-even kanina. Ito, yung values sa may just solar. Ba yun? Ay, just solar. Yung 9.3, I think. Tapos ito yung given. Yeah. Binago lang ito. So, to get the percentage, di-divide lang uli. Tapos sa may 100%, tumakuha 0.18. So, ang perfect choice daw, test lang to if 10 ah. If 10, ang sizing 10. Tanda ko na. 10 siya. Yung 10, pag sizing yung 10 to, kaya naging genere. Ito number. Kaya 0.18, hindi siya maglalampas sa may ano. Therefore, in conclusion, the number 10 wire sizing number is the perfect choice. So, ano tong table na to, sumobra. So, inverter sizing. The power rating must be equal or approximately to the solar arrays or higher than 10 or 20%. If the inverter does match a specific, we will have it will have a following. A below 1 cannot maximize the power of the solar arrays. A below 1 cannot maximize the power of the solar arrays that is capable. Parang kulang yung wording. And an inverter that is higher, the power rating of a solar array will have a drop in efficiency. So, yun. Either exact or equal, or pwede naman din 10 on 20. Pagka naman sumobra o tumaas masyado, magkakatrap ka ng efficiency sa may ano mo, setup mo. Therefore, for a 2,000 watts system, you will need 2,000 also or greater by 10 to 20%. Ayun, kaya explain ko na kanina. So, SPD sizing. It is advised to use higher than 15 or 25% for SPDs to attain better lifespan of the device. In reference, conductor sizing from probably another setup or step. For DCUs, an SPD that has the user rating of 120%. So just like dito sa may conductor sizing, may value dito na probably raised by 15 or 20% from original value. So sure natin diragdagan to ng ganong kalaki. So from here, ang value na mag-equal dito, tindagan ng 15%, tsaka 25 to probably. For ACUs, an SPD that has the user rating of 230 volts to 275 volts. Same again, yun lang, 15, 25. So, ibig sabihin ng UC, maximum continuous operating voltage rating or NCOV. So, yun lang. Yung SPD sizing, tsaka DC and AC circuit breaker sizing. Wait a sec. Lumampas ba ako? Lumampas ata ako. Lumampas nga. DC and AC circuit breaker sizing. So, let's multiply 125 or 1.25 the maximum current. Example, sa DC, 15.23 ampere multiplied by 1.25 equals to 19.00375 or approximately 19.04. Means we have to use 20 circuit breaker here. So 19, wala siyang 19. So ito na lang 20. Wag ng 15, masyadong masama. Layo. So sa AC naman, an inverter rating is 1 kilowatt. Dividing this by 220 volts probably value na to sa ibang step na naman na na reporter. By 220 value equals to 4.5 ampere. So again, 4.5 ampere multiplied by 125 from original value equals to 5.625. Therefore, it is a 6 ampere circuit breaker or an RCBO. Residual current breaker with overcurrent. Residual current breaker circuit. Para remember circuit breaker 2 whatever. So ito, magagamit tong na to, basta dagdagan lang ng 125% na ano na to. Saan ba nagamit tong hanep na to? Voltage drop. Voltage drop. Never mind. Not noted here eh. So, solar panel orientation. General rule. In solar panel orientation, number 1, countries in northern hemisphere should face south. 2, countries in southern hemisphere should face north. At ang number 3, tilt angle must be equal to the geographical latitude. Geographical latitude. Whatever that is, geographical latitude. That's why the tilt in the Philippines is 12 deg to 14 deg. Next. So, paano i-compute daw yung zero build computation? So, assume natin meron tayong 500 kilowatt per hour or monthly. So note dito na mayroon ng Philippines ay meron daw na 5 peak hours per day ng sunlight ba? Sunlight. So here. Let's see yung calculator. So 500 divided by 30. So meron kakaroon ng 16.6 kilowatt per day. So mag-equal din dito. So to convert, paano ko i-convert? Ay, ito pala. So 16.600 again, calculator, divide by 5. So multiplied by 5 peak hours. 3,320 watts for solar array rating. So naman for zero, to talaga yung dapat zero bill for zero bill assurance. 3,320 watts multiplied by 1.1 to original value equals this. Okay, para sure yung mga calculator. 320 1.1. Okay, tama. Or no. Parang pagkakatanda ko 8. Something to. Let me try again. So for number parang for number 8 ata ito eh. Number 8 of panels. For no panels. 2 divide by. Pag tama ito, tamang no panels nga ito. O tama, no panels nga. So, ganito lang pag-compute sa zero bill assurance. Division multiplied by itself by 10%. So in conclusion, if you have a 500 kilowatt hour, you might need a total of 12 or 13. If I remember, binago ko to. Tinagdagan ko yung value. Kaya na yung ginare. Binago ko yung value niya ng 200. If you have 15, if you have a 500 kilowatt per hour, we might need a total of 12 or 13. Depending number of solar in your setup to pay no more than in distribution utility. So, dinadagan ko siya. Dati 8. Dinadagan ko ng 4. Oo, mahigit dun. If you want the distribution utility to actually pay you, you need to add another 4 solar panels. Ito, sinasabi kong 4. So, yeah, hanggang dun lang.
Good day, everyone. So, we are the reporter for today. So, solar thermal system. I'm Jimmy Kitan from BC 3B. So, next slide. Solar thermal system. Solar thermal power/electric generation system collect and concentrate sunlight to produce the high temperature heat needed to generate electricity. All solar thermal power systems have solar energy collectors with two main components: reflectors, mirror that capture and focus sunlight onto a receiver. In most type of system, a heat transfer fluid is heated and circulated in the receiver and used to produce steam. Next. So, pakibalik nga sa unang slide. So, dito naman, yung solar thermal system is nagko-collect siya ng energy from the sun, then nag-produce siya ng high temperature. Then, pagkatapos nun, ito yung mag-generate ng high electricity. So, next. So, meron tayong 4 na types ng solar thermal system, or we can call CSP. So, CSP means concentrating solar power. So, first is a parabolic trap, solar tower, linear Fresnel reflector, and parabolic beam. So, sa report na to, itatakal natin kung ano nga ba yung pinagkaiba-iba ng parabolic trap, solar tower, and yung 4 na yan. So, yung 4 na yan ay nag-work under sa solar thermal system, and nagkakaiba-iba lang sila sa pagkuha ng sunlight. So, next. So, parabolic trap. Parabolic trap is a set of concave mirrors that concentrate solar rays on the receiver tube that is located in the focus. This tube can rock the sun around one axis, typically oriented north to south, to ensure the highest possible efficiency. The fluid flows through this tube and absorbs heat from the concentrated solar energy. Similar to a parabolic trap is a linear Fresnel system. This collector resembles parabolic trap but use long flat Fresnel mirrors. This technology is much cheaper to install but has a lower efficiency. And then, yan. So, yung parabolic trap ay ang ginagamit nito is a concave mirror na nagko-concentrate sa solar rays, and then nare-receive ng tube yung focus nito, and then yung halos sa similarity ng parabolic trap is a linear Fresnel system. So, next. So, dito ay ito yung parabolic trap natin. So, dito ay papaliwanag ko kung paano nag-ooperate yung parabolic trap. So, makikita nyo dyan na dyan sa parabolic segment, tatama yung araw dyan, And then pagkatapos, magre-reflect ito sa tube. And then sa loob ng tube, meron tayong tinatawag na fluid doon. So, ang fluid na yon ay yung fluid ay sa loob ay meron siyang elevated temperature. So, ano nga ba yung tawag sa fluid na yon? Tinatawag itong heat transfer fluid. Then after nun, madidistribute siya sa may ibang unit ng parabolic trap. So, next. So, ito yung mas malinaw na picture ng parabolic trap. So, next. So, ayan dito. Di ba sabi ko kanina, kapag tumama yung sikat ng araw sa parabolic segment, mag-reflect ito sa tube, and then sa loob ng tube, meron tayong fluid doon. And yung fluid doon ay tinatawag na heat transfer fluid, which is ito yung elevated temperature. Tapos, madidistribute siya sa ibang unit ng parabolic trap. And then, kapag tapos nun, ay pag-iinitin na yung fluid, papunta na sa heat exchanger. Then, kapag nakapunta na to sa heat exchanger, magiging steam na siya. And then, kapag katapos niya mapunta sa steam, pupunta na siya sa may steam turbine. Then, after mapunta nito sa steam turbine, mapupunta na siya sa generator. Then, after nun, magge-generate na siya ng electricity. So, ito yung sa diagram na to, makikita mo dito kung paano siya nag-operate and generate. So, yan. Next. So, ito lang yung actually para mas maintindihan natin mabuti kung ano yung paano talaga nag-operate yung parabolic trap. So, next. So, ito yung heat exchanger. So, ito lang yung basic heat exchanger natin. So, yan. Meron tayong hotter before, cooler after, hotter after, and cooler before. So, yan. Next. So, sa actual naman, kapag nagpunta kayo sa mga site, so yan, ayun yung makikita yung heat exchanger talaga, ano. So, yung kanina pa, basic lang siya, hindi siya ganun talaga. Ito talaga yun. So, next. So, ito yung tinatawag na steam turbine. So, ano nga ba yung steam turbine? So, ano nga ba yung steam? So, the steam is converted into mechanical energy in a turbine which power a generator to produce electricity. Solar thermal power system have tracking system that keeps sunlight focused onto the receiver throughout the day as the sun changes position in the sky. Solar thermal power plants usually have a large field or array or collectors that supply heat to a turbine and generator. Several solar thermal power facilities in the United States have 2 or more solar power plants with separate arrays and generator. So, dito sa may steam na to, yung blade niya is nade-design according sa steam. Unlike sa may wind turbine, sa wind turbine, hindi. Basta meron isang turbine na nakadepende siya sa may water kung paano nabubuo yung blade niya. So, yun lang. Next. So, tapos na yung report ko. So, ang susunod sa akin is si Michael. So, ipapaliwanag niya yung susunod dito. So, yan. Thank you.
So hello everyone, my name is Bong Christopher Mercado, your reporter in solar thermal energy. So yeah, linear Fresnel reflector. So the design of this type is the combination of parabolic trough and solar tower. This uses flat mirrors instead of parabolic mirrors used in parabolic troughs. These flat mirrors moves in one axis only, unlike solar tower and parabolic dish, which moves in two. It adapts the working of solar tower, where the mirror on the ground collects the light from the sun and reflect it towards a fixed receiver located above. So, ito yung example ng linear Fresnel reflector. So, dito ang gamit daw ay flat mirrors. So, dito nagko-conduct yung itong flat mirrors from the sun at tatama yung energy from the sun dito. Yan. So, yan. Previous designs generates steam directly without the use of HTF, which are now obsolete. LFR nowadays also uses HTF to generate steam. So, ayun, ang pag ano daw nito, meron daw ditong HTF. Ayan. Sa collector. The classic LFR has only one linear receiver on a single linear tower. To increase optical and ground use efficiency, the improved design called the Compact Linear Fresnel Reflector, or CLFRS, use multiple receivers for each set of mirrors so that adjacent mirrors have different inclinations in order to target different receivers. So next is ito yung yung general description ng linear Fresnel reflector. So dito ito yung primary mirror na nagre-reflect sa energy from the sun para magpunta sa evacuated glass tube. So yan. Ito naman yung secondary mirror. So dito yung lagpas na sunlight na galing sa nasa ibabang mirrors, yan. Tatama pa rin siya sa evacuated tube natin. So one big disadvantage with this design is the shading effect of adjacent mirrors, which can be encountered only by utilizing more ground space, which increases cost. So yan. Number 2 is very high temperatures are not produced as compared to a parabolic trough or a solar tower, and therefore the efficiency is less. So dito, ang gamit daw dito ay flat mirror. So hindi ito na-produce ng very high temperature. So ito daw ay efficiency. Yung efficiency daw nito is mas mababa. So yan, ito nga siya. Ito yung mga mirror, ito yung blue. Tapos ito namang yellow na to yung energy from the sun. So ito yung evacuated glass tube na nagka-conduct ng energy. So yan, next. Parabolic dish. So dito, ito yung parabolic dish. Yan. This consists of sets of flat mirrors combined to form a large parabolic dishes that is attached to a motor sensor which tracks the movement of the sun in dual axis. So ito daw palang may motor siya na nagmo-monitor. Parang motor sensor siya na sa sensor niya kung nasan yung sun para mas maano niya yung pag-conduct ng energy from the sun. So the collected energy from the sun is being concentrated to the PCU located at the focal point of the dish. So, ito yon yung PCU. Yan. With Stirling engine. So, the thermal receiver, which is heat exchanger, transfer its heat to the Stirling engine, causing it to reciprocate. And causing it to reciprocate. This reciprocating movement causes the rotation of the electric generator. These dishes can concentrate the sunlight much better parabolic trough, and the fluid run through them can reach temperatures upwards of 70 degrees centigrade. So, because of the limitation of size and small quantity of fluid, parabolic dish collectors are suitable for small scale power generation up to few kW. So ito pala yung itsura ng Stirling engine. Ito. Sa loob nito. Ayun yan, ito. So Stirling engine can be hard to understand. Here are the key points. Every Stirling engine has a sealed cylinder with one part hot and the other cold. The working gas inside the engine, which is often air, helium, or hydrogen, is moved by a mechanism from the hot side to the cold side. When the gas is on the hot side, it expands and pushes up a piston. When it moves back to the cold side, it contracts. So, ayan. Next. So, ito daw yung largest solar thermal power station. Number 1 is Ouarzazate Solar Power Station. So, ang capacity nito is 510. Country nito is Morocco. Type, parabolic trough, and solar. Ayan. So, makikita natin dito yung 1, 2, 3, 4, 5, 6, 7. 7 largest solar thermal power station. So, ito pala, may pinakamalaki pa pala. Yung Mohammed bin Rashid Al Maktoum Solar Park Phase 4. So, ito naman ay ang capacity nito 600 and 100. Pero ito daw ay still under construction. So, ito yung example niya. Ay yung figure ng Ouarzazate Solar Power Station. Okay. So, ayun. Yun lang po at maraming salamat. Thank you for listening.
So, heat transfer fluid. Jermichael Olian reporting about heat transfer fluid. So, wait a sec, mababa ko lang to. Heat transfer fluid is a gas or liquid that takes part in heat transfer by serving as an intermediary in cooling on one side of a process, transporting and storing thermal energy and heating on another side of a process. Heat transfer fluids are used in countless applications and industrial processes requiring heating or cooling. So this naman, so itong definition bale sa gets naman natin sa Google. Pero sa atin dito sa heat transfer fluid na ginagamit sa, let's say, solar energy na to, nagamit siya pang transfer ng init sa pang move ng init para makamove ng turbine as steam. Next. So, next ay, bakit nga ba HTF? Ba't hindi na lang tubig na mas cheap pa? So, ito yung sagot. These HTF have high heat capacity and can maintain a longer period of time to store it to a tight vessel. Like the thermal tanks in the picture. Wait, a second, to thermal tanks. So, preserve the heat for nighttime or other weather where there's no direct sunlight. Ano ba? Hindi ko makita. In contrast to the direct system water. So, ang pagkakaiba nila bale, yung tubig, pagka wala ng araw, minsan kasi di tumatagal yung init niya. Compare sa mga HTF na, let's say, ang maximum dito ay, example dito na 550 Celsius. Tapos synthetic oil 400. Pero yung tubig na gaano agad, naboboil agad or nag-i-steam. Ito, pwedeng itago sa tight vessel para magamit sa later use. So, next. Types of HTF. 1. Air. 2. Water. 3. Molten salt. 4. Glycol-based. 5. Glycerol-based. Second. Tanggal. Glycerol. Glycerol-based. Tapos synthetic oil. Note, air and water is the direct system which has no reserve power. Note, it depends on the area of the site where these are chosen. It also depends on their characteristic. So makikita natin yan sa mga susunod na slides. Yung ibig sabihin ng it depends on their characteristic. Kasi pinipili din kung gaano kainit talaga minsan sa lugar. Sa lugar. So, heat transfer fluid again. The following are the characteristics being considered when choosing an HTF that is used in a power plant. So, operating temperature. So, yung init niya. Overall efficiency. Life cycle. Katagal. Sa heat transfer capability. Yung sinabi ko kanina, heat transfer capability. Sa heat storage naman, ito pala sinabi ko kanina dito. Overall safety. Cost. Pag cheap, pwede namang yung wala nga lang tulad kanina, air and water. Wala nga lang reserve power na tulad ka naman na i-store sa tight vessel. Sample, if by heat storage aspect from the study of UASA of 2017, the molten salt can heat up to 550 Celsius degrees versus 400 of synthetic oil, which means molten salt can hold a greater heat in a storage aspect. So sinasabi nito na yung molten salt magandang candidate na HTF para sa heat storage aspect. So next, solar tower. So ito. Tracking. So, ang solar tower daw ay nabubuo ng tower. Saan ba yun? Nabubuo siya ng isang tower. Tapos itong mga heliostats na to. So, itong mga bilis na naman to nasa logging power plant. So, again, mabasa. Tracking mirrors called heliostats controlled by many computers. These can concentrate up to 1,500 times from its normal intensity. These heliostats move in dual axis modes. Focuses all its dual axis modes X and Y. It focuses all its strength into a receiver which contains the HTF located at the top. At the top, ito receiver. HTF nandun. Tapos ito yung mga tubes. At the top, like in a picture, ayun sabi ko nga, it can heat up to 600 Celsius where there's multiple connected tubes like in the parabolic trough where HTF follows generating steam to power the turbines. So sabi 600. So dapat pumili ka tayo ng HTF dito na maganda katulad sabi doon na lalampas ng 600 or saktong 600 yung survivability. Para, where is it again? Para magkaroon ng overall safety. So next. Some also gas to the tight vessel. Sabi ko dito yung tubes sa dalawa. To preserve the heat which requires a specific HTF, parang kanina yung again, molten salt to hold a specific temperature to last. This is used just like earlier in the case that we don't have any sunlight, whether it is about weather or daylight. Yeah, you know. So basically that sunlight goes here, redirects here. This thing goes up to 600 Celsius. And the tubes connected here stores to the tight vessel. Tapos to turbine generating steam. Tapos kuryente. That's it. Yun.
Photovoltaic system. This type uses the energy from the sun and converts it into electricity using a solar panel. Component of a solar panel: the glass, anti-reflection coating, metal grid, N-type silicon, P-type silicon. This is the silicon junction, the N-type and the P-type. Next is the metal plate. Around 5% of energy from the sun is already lost due to reflection once it hit the glass, which is the top layer. Anti-reflection coating. To avoid further losses of sun's energy upon entering the glass, to prevent losses due to reflection, the silicon, being a semiconductor, is a bit shiny. Exposing it directly to sunlight may lose about 30% of sun's energy to reflection. Photovoltaic effect. Generation of voltage and electric current is a material upon exposure the light, a physical and chemical phenomenon. To achieve this effect, a material which, when struck by sunlight, will exhibit some characteristic of a conductor is needed. When the silicon semiconductor absorbs energy from the sun, the photon which the sunlight have could knock an electron out of its orbit within an atom, making it free to move within the system in random. Pure silicon is not enough to achieve making PN junction. This will be achieved through doping. Doping is pag-a-add ng chemical components dun sa may mismong gagamitin mo na chemical. Doping is the addition of the substance in a semiconductor for the purpose of modifying its electrical conducting. For example, is the magdo-dope tayo dun sa N-type side yung phosphorus and dun sa P-type side is yung boron. Yung dopant is yung in order to create silicon junction. dapat sa may n-type mas mataas lagi ng isa. Kunyari, halimbawa, 4 valence electron dun sa may idinodope mo. So, kailangan mo magtaas ng isa. So, dapat maging 5 valence electrons naman yung idodope mo or isasama mo dun sa may dopants mo. Next naman, kung paano yung sa may p-type. Kaya nakuha yung boron is mababa naman siya ng isa dun sa pinaka gagamitin mo na valence electron, di ba yung 4 valence electron? So, dapat ibababa mo naman siya ng isa. So, magiging 3 dapat siya na valence electron. So, sa n-type side, yung phosphorus and sa p-type naman is yung boron. Since there is the rush of electron from the n side towards the p-type, the charge of the two sides will be reversed, making the boron dope p side become slightly negative and the phosphorus dope n side slightly positive. Sa may n-type, ito yung heavily doped, tapos yung sa p-type is yung slightly doped. Next naman yung depletion region. Depletion region yung nasa gitna ng glass tsaka ng metal grid. Rush of electron that quickly form a barrier between the two sides. Equilibrium is being reached, them electrons stop flowing. Ito yung pagkakasunod-sunod ng process. Sunlight enter the n-type side, then penetrates the depletion region. Next is this process knows an electron out of the band as many as it can, creating pair of free electrons and hit and hole in the depletion region. The electric field drives the pair out of the depletion region. The free electron goes into the n-type side and holes in the p-type side, resulting in a higher concentration of both. Sa top layer yung n-type and sa bottom layer yung p-type. Sa n-type is yung thin and also heavily doped. Next naman sa p-type naman is yung thick and lightly doped.
So, how do solar cell work? Another thing that is needed to achieve by the silicon semiconductor is for it to exhibit the characteristics of a battery, where there is an imbalance of charge in both sides. Therefore, two sides should be created. So, the called PN junction, making the two sides of the junction positively charged and negatively charged. So, pure silicon is not enough to achieve this. This is achieved through doping. So, doping is the so, ito daw ay upang ipakita ang katangian ng isang battery kung saan mayroong hindi balance na pag-charge sa both sides. Ang tinatawag naman na PN junction ay gumagawa ng two sides, ang positive charge at ang negative charge. So, doping is the addition of other substance in a semiconductor for the purpose of modifying its electrical conductivity. So, ang doping naman na tinatawag ay ang paghahalo ng substance sa tinatawag na semiconductor upang makalikha ng iba pang substance. So, here is now another questions. So, what substance should be used as dopant for the silicon to become negatively charged? So, sagot dito ay, so para magawa nating negatively charged ang silicon is kailangan natin mag-doping. So, ang gagamitin nating dopants is si phosphorus. So, bakit si phosphorus? Kasi kung titingnan nyo sa periodic table, magkatabi sila. So, hindi sila nagkakalayo ng characteristics and mas mataas ang electrons ni phosphorus kaysa kay silicon. Dahil alam naman natin na kapag sinabing electrons, it is negative, so need natin ng mas mataas na electrons kaysa kay silicon. So, next. What substance should be used as dopant for the silicon to become positively charged? So, dito naman, ang kailangan naman natin gawin is gawing positive si silicon. So, paano nga ba natin siya gagawing positive? So, sa kanina, need natin mas mataas na electrons. So, dito naman, obviously, need natin ng mas mababa na electrons, which is si aluminum. So, bakit si aluminum? Kasi, hindi din sila nagkakalayo ng characteristics ni silicon. And mas mababa yung electrons ni aluminum kaysa kay silicon. Pero mas mapapadali ito kung hahanap ka ng mas mababa na electron. So, pero kasing characteristics din ni silicon. So, sino nga ba ang pwede? So, kung titignan nyo sa periodic table, si boron ay pwede. Kaya ang sagot natin sa tanong na dalawang tanong na to ay on the N-type side, phosphorus is being used as the doping materials, while on the P-type side, it's boron. So, since there is the rush of electrons from the N side towards the P side, the charge of two sides will be reserved, making the boron dope P side become slightly negative, and the phosphorus dope N side slightly positive. So, dahil merong rush ng electron mula sa N side papunta sa P side, so, ang charge ng two sides ay magbabaliktad na. Ginagawang boron dope P side ay magiging slightly negative. At ang phosphorus dope N side naman ay magiging slightly positive. This rush of electrons will quickly from a barrier between the two sides called depletion region. So, depletion region is yung region na walang pre-electrons and wala din siyang holes. Then, siya yung nagsisilbing barrier sa dalawang sides. It's either positive or negative. So, in here, equilibrium is being reached, then electron stops flowing. An electric field is definitely created. The silicon junction is now exhibiting characteristics of a battery. So, dito, naaabot ng equilibrium. Pagkatapos ay hihinto ang pag-agos ng electron, then ang isang electric field ay mabubuo. So, the silicon junction magpapakita na ngayon ng characteristics ng isang battery. Sunlight enters the N-type side. Then, penetrates the depletion region. This process knocks an electron out of the bond as many as it can, creating a pair of free electrons and holes in the depletion region. The electric field drives the pair out of the depletion region. The free electron goes to the N-type side and holes in the P-type side, resulting in higher concentration of both. So, yung liwanag daw ng araw ay pumapasok sa N-type side, pagkatapos ay tumatago sa depletion region. So, sa process daw na ito ay tatanggal ng isang electron mula sa bond hanggat maaari itong lumikha ng isang pares ng electron at holes sa depletion region, at ang electric field ay nagtutulak sa pair palabas ng depletion region. Ang electron ay mapupunta sa N-type at holes sa P-type at magre-resulta sa mas mataas na concentration of both. So, ito yung pagkakasunod-sunod ng parts ng photovoltaic. So, the glass, yung glass, so, siya yung nasa taas. Sa kanya unang papasok yung araw. And then next is the anti-reflection coating. So, kaya may anti-reflection coating para kapag pumasok na yung sikat ng araw, hindi na siya makakaalis or hindi na babalik. So, next is the metal grid. So, yung metal grid is metal siya na butas-butas siya. So, ang sunod ay N-type at P-type ng na silicon. So, ang last ay ang metal plate. So, ang metal plate ay metal din siya pero wala siyang butas. Isang plain na metal lang siya sa pinakailalim. So, practically in solar panel, the top layer, which is the N-type side, is thin and heavily doped, while the bottom P-type side is thick and lightly doped. This results into bigger depletion region, thus pre-electron and hole pair is being generated in a wider area, which in turn produces more electricity. So, sa isang solar panel ay ang taas na layer na kung saan ang N-type na bahagi ay manipis at mabigat na dope, habang ang ilalim na P-type na bahagi ay makapal at magaan na dope. So, nagre-resulta ito ng mas malaking depletion region, kaya ang pair ng electron at holes ay nabuo sa isang mas malawak na lugar kung saan ay nagpo-produce ng mas maraming electricity.